In this series of videos, we're going to be covering a topic in physics. We're going to be covering the topic called kinematics. This is a topic that's usually covered early in a physics course in the first few weeks and in the first few chapters of a physics textbook. Sometimes this is called kinematics. More precisely, it's called constant acceleration kinematics or constant acceleration motion, or the chapters might be called things like one-dimensional motion and two-dimensional motion and free fall and projectile motion. Those are all the kinds of topics that we're going to be talking about here. Kinematics, constant acceleration, projectile motion. Those types of topics that are usually covered early in a physics textbook and early in a physics course. So this is generally important information early in a physics course. And it's also important to learn because very often as you move on to the later portions of physics, oftentimes you're going to have to solve a problem that involves kinematics as a portion of that. So it's important to master kinematics early in your course. And this is also an important topic on standardized tests, such as the MCAT. In these videos, now that I think about it, I can kind of break this down into 4 different topics. And actually, I think in this particular series of videos, I'm just going to cover this. In this particular series of videos, too, because those are important as well. But I think it's actually going to take quite a bit of work just to cover this. So we're going to cover one-dimensional motion for constant acceleration kinematics, and hopefully I'll find the time to make some series of videos on these other topics as well. Now, projectile motion is just a type of kinematics. Projectile motion is when you have something that's moving only under the force of gravity. A projectile that's moving only under the force of gravity is what we usually mean by projectile motion. So that's really projectile motion in one dimension. That's kind of a special case of one-dimensional motion. But this is so important, I think I should put this, if I have the time, I'll just put this in a separate series of videos. Projectile motion in 2 dimensions. But again, maybe each of these is going to take enough work that they should be in separate series of videos. So this series of videos is for this topic. Now this is very important in and of itself. And these other topics really very well unless you start here. So if you're finding this material difficult, I hope that you won't jump ahead to these other series after I've made them, but instead watch through here as well. Otherwise it's going to be hard to understand what we're talking about here. So we're going to focus on just one dimension. Maybe I should mention that we're going to be focusing on translational motion. There's another type of kinematics that's called rotational. So you could also focus on how something rotates. That would be a good thing to make videos about, but that's not what I'm going to be working on right now. Instead, I'm focusing on translational. Translational motion is just we're going to be talking about movement from one place to another. We're not going to be talking about something that's rotating around itself. Rotation is a separate topic. Sometimes you might hear the term free fall. I think free fall is pretty much okay, now like I said, so far I haven't even made these yet. I'm just working on this, but maybe I'll find the time to get onto these topics as well. Now, when you learn about two-dimensional motion, an X component and a Y component. When you're working with two-dimensional motion, the trick is to think separately about the X and Y components of the motion. And that, in a way, that doesn't really apply to one-dimensional motion, because one-dimensional motion really only has one component. However, again, the main reason for this material, or one of the main reasons, is to help you get prepared for two-dimensional motion. So even when we're talking about one-dimensional motion in this series of videos, I'm still going to talk about the X component, or the Y component of the motion. I'm still going to draw an X-axis or a Y-axis. Now, since we're doing one-dimensional motion, there's only going to be one component that we care about. So usually we're just going to focus on the x-axis, and we won't even bother with the y-axis. Or if we draw a y-axis, we won't even bother drawing an x-axis. In one-dimensional motion, you only need one axis. In one-dimensional motion, you only need one axis. Specify which axis we're talking about. So for example, I'm never going to write down this symbol for acceleration. I'm never going to use this symbol. Instead, I'm either going to say the x acceleration or maybe once in a while the y acceleration. Because it's really important to get into the habit of always thinking in terms of components. I'm still always going to specify what the axis is that we're using. I think a lot of textbooks might not do that, but again, our main goal here is to have this subject prepare us for two-dimensional motion. So it's really important that we get into the habit of thinking in terms of components from the start. So again, we're not going to worry about this symbol is not going to be useful to us. Instead, if we're using an x-axis, I'm going to call it a sub x for the x acceleration. And if we happen to be using a y-axis, I'll call it a sub y for the y acceleration. I'm always going to specify what axis we're using, even though for one-dimensional motion we only need one axis. So I might be using a little bit more notation than your textbook would use for one-dimensional motion, but that's because I think that's going to motion, we're going to have both axes, both an x and a y. I hope what I just said made sense, and if it doesn't, it'll become apparent pretty soon as we go of these videos by going to my website. There's a link to my website in the info box, and here also is the address of my site, www.freelance-teacher.com/video.mht www.freelance-teacher.com/video.mht. Or again, you can just click on the link in the info box. This series of videos is intended for people who are finding this material to be difficult. People who find the material difficult, and there's two consequences of that. First of all, because I'm intending these for people who find the material difficult, I'm going to try to go through the material very slowly. I'm going to repeat myself a lot, and I'm going to try to give lots of examples, lots of repetitious examples. And I hope that that will be helpful to you if you find this material difficult. But on the other hand, if you don't find this material difficult, the result might be that you find these videos very boring. If these videos are too boring because this material is too easy for you, then I just recommend learning the material in some other way, maybe from your class or just straight from your textbook. But my intended audience is going to be people who find the material difficult, so I'm going to try to go very slowly and be quite repetitious and go through lots of examples. Now the other consequence of this is, again, since I'm intending this for people who are finding this material difficult, people who find they make lots of mistakes when they do these types of problems, I'm going to adopt a very bossy and dictatorial and maybe even a little bit rude tone in these videos, in the sense that I'm going to be telling you exactly what to do. I'm going to try to give you a recommendation for the exact best way to do these problems, the exact systematic approach, and I'm going to be very bossy about the notation that you use. I'm going to try to put on the board the exact type of notation that I recommend for doing these types of problems, and then I'm going to really hector you to use that exact notation. If you get the question right, but you're not using the same notation as I'm using on the board, I'm going to encourage you to go back and do the examples again. And I'm going to be doing all this because, again, I'm intending these videos for people who find the material difficult and who tend to make a lot of mistakes. Well, if you find this difficult and you tend to make a lot of mistakes, it's important to have a very systematic approach and a very standardized notation. And we're going to go through a type of notation that will help you to avoid many of the common mistakes if you adopt it. Now, if you don't find this material difficult, then it's not necessary for you to be so systematic. And if you don't find this material difficult, then it's not necessary for you to do the problems with the same precise notation that I'm going to be using on the board. But if you don't find these problems difficult, why are you watching these videos in the first place? So again, I'm intending these videos for people who find this material to be challenging and difficult and who find themselves making lots of mistakes. And as a result, I'm going to try to tell you exactly what I think is the best way, not just to approach the problem, but exactly what I recommend writing down at each step of the problem. And I'm really going to strongly encourage you, even to the point of being rude, to do the problem the same exact way that I'm doing it on the board. Now, eventually, hopefully, you're going to get to the point where you do not find these questions difficult anymore. And when you get to that point, you don't need to be quite as systematic, and you don't need to follow the same exact notation that I'm using. But as long as the problems are difficult, I'm going to encourage you to try to imitate what I'm doing exactly as we go through the problems. And I hope that you'll forgive me if I come off as being bossy or rude as I'm doing that.